Alright, in this video we're going to talk a little bit about how to communicate between Arduinos. Now, I've come up with a little circuit here that'll demonstrate this very easily, and we'll also take a look at the code and see how everything works. So basically all I have set up here is two Arduinos connected with a serial communication link, and each of the Arduino has an LED on digital pin 13. Now, what I'm going to do is send a message to the first Arduino from the computer. Then it'll either light up the LED connected to it or pass the message along and light up the LED on the second Arduino. Also, after this Arduino has received and executed the message by either turning the LED on or off, it will send a message back to the first Arduino, which will then send the message again to the computer. So from the computer we can control the LEDs on either one of these Arduinos. Now, the first Arduino board here, I'm using two serial communication links. I'm using something that's called a software serial that basically just allows you to do serial communication on any one of your digital pins. So for this I'm going to use digital pins 2 and 3 for that, while digital pins 0 and 1 are used for the regular serial communication that is going to be used for the computer. And then on the second Arduino I'm just going to use the standard serial communication on 0 and 1 as well. So anyways, that's the circuit. Let's take a look at the code and see how this whole thing works. Alright, so the first piece of code we're going to talk about is for the first Arduino, or the Arduino that's connected to the computer. So the first thing you'll see here is that I've included the new software serial library. Now that one isn't packaged with the Arduino, so you'll have to go out and install it. To do this, it's pretty easy. Just go to the Arduino's homepage, click on Reference, then go to Libraries, and you'll see here's the regular software serial library, but we're using the new software serial library. So just go ahead and install that, and you should be good to go. The only reason I had to use this is because for some reason I can't transmit with the regular software serial library. Might be different on your computer, but for me it just doesn't work. So to set this up, then you go new software soft serial, and we're going to call it Arduino to transmit to the second Arduino, and we're going to use digital pin 2 for the receiving and digital pin 3 to transmit. Now to connect this all up, this RX is connected to the TX of the second Arduino. This TX is connected to the RX of the second Arduino. So it's just the opposite. Always remember to do that. Okay, so once you have that done, then we set up an integer and where we're going to store all the incoming data from the second Arduino and from the computer. Okay, digital pin 13 as our output for the LED. We'll start up our regular serial at 9600 and our software serial at 9600 as well. Okay. Now the first thing we do in my loop is always check the Arduino read, which is the software serial. So we're constantly checking that and storing whatever comes in as reader 0. Because there's no buffer with the software serial. So if you're not listening to it, the data will be coming in and be lost. So you can't just check it periodically, you need to always check it. So that's what we're doing here, and then we'll come back to what this if statement here means in a second. But anyways, so moving on, if we have a little serial data available, that basically means that when we send a message to the Arduino, it's going to be thrown into the serial's buffer. This is the regular serial communication I'm talking about now. So when we have a serial data available greater than 1, that means our buffer's getting filled up. We can go through a little for loop and store the whole message into reader, which was that variable I showed you before, right up here. Okay, we fill that up with our message. And one thing that I always have problems with serial communication is these delays. If you don't have them in there, things just get screwed up. The message gets garbled or it doesn't get received at all. I don't know, just don't forget to have your little delays in there every time you read from it. I guess it gives it time to settle, gives it time for the message to come through. I don't know. But anyways, so now your whole reader was filled up, and now you can start comparing it. So What we basically have here is if the first byte is 1 and then second is O, third is N, then we make digital pin 13 high. So that basically means 1 is the first Arduino, and it could either be on or off. So then that basically just controls that first LED. Now to control the second Arduino, what we do is same thing, but instead of turning an LED on, we pass the message along. I don't know why I have those in there. Okay. So what it does is does the software serial print to on. And if it's off, to off. It just passes it along. Now, what I have here is if the incoming message is A on, I do a serial print back to the computer letting us know that the second Arduino's LED is on or second Arduino's LED is off. We'll get more on this when we look at the second Arduino's code. Then finally we do a little flush of the reader. So we just go through a little for loop and dump everything, all of its entire message as 0. So it's just a big string of zeros. Okay, now you can see here, well, we'll come back to this. Let's take a look at the second Arduino's code. It's a lot easier. There's not much here because I'm using the regular serial communication. So same thing. We set up a couple variables. Digital pin 13 is an output. Serial can start at 9600. Same thing, if a buffer's filled up, dump the whole message into reader. Then we come down. If it's 2 is on, we make it go high. Then we have a little delay here. And then we transmit back. A is on. I don't know why I have these number signs. A is on. And same thing with 2 off. We then send a message back saying A off. And then we flush. Now this A thing will come back when we look at this, because when it's always looking at the serial or the software serial communication, if it receives that A, it'll fill up reader with all software serial data. Okay, that flags it basically. And you'll notice I have I is equal to 1 here because 0 is already A. So I have to start it at 1 for the reader. Okay, then down here we see if we have A is on or A is off, we send a message through the serial that letting us know. Now let's just open up the port and show you what happens here. So I'm going to show this again physically so you can actually see the LEDs. But when I say 1 on, it turns the first LED on, or 1 off, turns it off. Now if I go 2 on, look, 2's on. Wait, let me do it again here. 2 off. Oh, there we go. Okay, LED on. Arduino 2 is off. Okay, 2 on. There we go. Okay, I didn't have power there. So you see I'm getting the message back, letting me know that it's on or off. It's kind of like sometimes it's called a handshake, where we know that the second Arduino has got the message and is ready to receive another message. Alright, so now you probably want to see these LEDs actually turn on. So let me open up a window here in the Arduino and we'll send that message over. So right now I'm going to say number 1 on. And there it is, turning on. And now I'm going to say 2 on. 2's on, and I got the message back. Let's go 2 off. 2's off, I got the message back, and let's go 1 off. There we go. Okay, and that's how to communicate within the Arduino. Thanks for watching.